Hey, here we go. Let's try part two. Now I gave you an idea what a radian is. Now we're going to try to be able to switch from degrees to radians, going that way, or go radians to degrees. So from last video, we went through that's 90 degrees, and then we figured out, oh, there's a quarter of a circle, so it ends up being pi over 2. But if you can't tell how much of the circle is, how are we going to figure it out? And it all comes down, it's a proportional thing. So we're going to be setting up a couple of fractions, and here's what the proportion looks like. So degrees go on this side with the 360, and radians go over on this side with the 2 pi. So 360 is one time around the circle, and 2 pi is one time around the circles. So if you know degrees, you put the degrees here and figure out the radians, or if you know the radians, you put the radians here and then figure out the degrees. I'm going to go ahead and say, yeah, that's true. It is true. But you can go ahead and reduce. One of the things we're going to have to do if you're doing this stuff by hand, like on the SATs, you're probably going to have to do it by hand. You're going to want to make it as simplified as you can before you try to figure it out. So since you know 360 is equal to 2 pi, we can divide both of them by 2 and get 180 equal pi. So halfway around the circle is a pi. That's how long that arc would be. It's a semicircle. So, okay. So you can use either one, but the equivalent, I'd say use this one. But of course, in the first one, I don't. Convert 120 degrees to radians. So that's degrees. So we put it where the D goes. So it's right up here. Once again, I'm going to try to do this by hand. So, okay, 120, I can take out the zeros. So reduce first before you cross multiply. The little blue ones down here are cross multiply. And yeah, so you want to reduce and then cross multiply. So cross off the zeros, take out the factor of 10, then 12 and 36. Oh, okay, that's 12 goes into 36 3 times, so that's 1/3. So I reduce the 120 over 360 down to 1/3. Now that I have it like this, I do the cross multiply. Going this way, I'm going to get the 3r. And going this way, I'm going to get 2 pi. So now I got 2 pi equals 3r. I want to solve for r, so I divide both sides by 3. And I get r equals 2 pi over 3. Or you can go 2/3 pi, but usually convention is put the pi up top. I could put the pi to the side. I could have 2/3 and then a pi, but that's normal protocol is leave the pi up in the numerator. All right. That's how you'd go from degrees to radians. And now one more. We go radians to degrees. So I got 4 pi over 3 to degrees. Here's my little formula again. And so now I've got the radians, and I'm going to figure out the degrees. So the 4 pi over 3 is going to go over here in the numerator of this one. Now, the nice thing about this is right off the bat, we see pi on the top and pi on the bottom, so we can cancel those two things. And that ends up leaving us with d over 180 is equal to 4/3. Here we go with a cross multiply again. You go this way, you get the 3d. You go this way, you get the 720. Now, hopefully, you'll be able to figure it out from here if you didn't have a calculator, but you divide both sides by 3, and you find out d equals 240 degrees. Now, I'm going to admit I forgot to put little degree symbols in here, but because we have radians and degrees to be to be precise, you should be putting a little degree symbol here. I did not in this one. Okay, I think that is a unit on converting from radians to degrees and degrees to radians. I hope that helps.